Japan's space agency JAXA is preparing for its most ambitious small-body mission yet, the Next Generation Small Body Return, or NGSR. This mission targets a pristine comet to bring back samples from the dawn of our solar system. JAXA has a long and successful history of small-body exploration, continually expanding our understanding of the solar system's history. Their historic successes with the Hayabusa and Hayabusa 2 missions demonstrated their capability in collecting and returning samples from asteroids. The next major mission is Martian Moons Exploration, MMX, but after that, JAXA is setting its sights on a much more challenging target, a comet, with the NGSR mission. The NGSR mission's main target is the Comet 289P/Blancpain. This is a unique and intriguing small body with an interesting history. Originally discovered in 1819, 289P/Blancpain was considered lost for 2 centuries before its rediscovery in 2003. It was initially mistaken for an asteroid. Crucially for NGSR, Comet Blancpain has a relatively low rate of gas and dust production, making it a much safer environment for the spacecraft to perform proximity operations than a highly active comet. So why a comet? Why not another asteroid like Ryugu? Asteroids have been heavily altered by impacts and solar weathering. Comets, however, especially those beneath the surface, hold potential samples of primordial ice and dust from the very beginning of the solar system. Spending most of their lives far from the sun, comets act as miniature deep-frozen time capsules, preserving interstellar materials in their original, pristine state. NGSR has 2 major scientific goals. The first is to understand the kind of stars that forged the material that became our sun and planets. Since heat and alteration have compromised pre-solar material in asteroids, finding these interstellar materials in their original pristine form on a comet is crucial for truly understanding the early solar system's chemical makeup. A truly exciting possibility is finding pristine pre-solar organic materials, the building blocks of life, which would provide direct evidence that the chemical precursors for life were delivered from the stars. The second major goal for NGSR is centered around solving the mystery of planet formation. We still don't fully understand the mechanism by which microscopic dust grains clumped together to form kilometer-sized planetesimals, the building blocks of planets. NGSR will deploy seismometers and use bistatic radar to probe the comet's internal structure, searching for meter-sized voids that could hold clues to how planetary formation initially started. Let's look at the timeline and components of this ambitious mission. The NGSR mission is currently planned for launch in 2034, and the total duration from launch to sample return is expected to span 14 years. The spacecraft will have 2 main components: a deep space orbital transfer vehicle for the cruise phase, and a dedicated lander for actually touching down and collecting samples from the comet's surface.